Welcome everyone to another edition of the Subseasonal Forecast Contest. Today is Friday, December 18th. We submitted our forecasts on December 15th. Again, these are the 16 to 20 day HDD forecasts. And we're fortunate today to have a special guest. Professor Andrea Lang is here from the University of Albany. So we're going to spend quite a bit of time here in just a minute talking about some of the research projects that Andrea has been involved in, and specifically stratospheric research, which is certainly a hot topic for subseasonal research. Okay, before we get into that, we'll start with our usual attribution, and then we'll get into the forecast and talk about the research and whatnot. So let me switch gears here. I'm going to look at our last verification period, and I believe that was from this one. Nope, one more. There we go. Okay, so our last forecast verification was the forecast made from November 24th, you can see up here, and the target window was December 9th through the 13th. So it's just verified here a few days ago. And in terms of the columns here on the left, you've got your different forecasters, ranging from human to some of our sort of model inputs. And then your forecast mean, your spread or sigma value, kind of like a one standard deviation sigma. And the CRPS is our performance metric. We have a couple, but this is the primary one we use. And then formula and maps. So I'll just sort by the CRPS. And yeah, we'll just kind of start by taking a look at how folks did. Let me just mention here too, just to get our bearings, the verification came in at about, you can see at the bottom here, verification was about 108 HDDs. And let's see, the 30-year average was close to 137. And where's the 10-year average? The 10 years up there, 125. So definitely a warm forecast, on the warmer side of the 10 and 30-year normal. In terms of some of the inputs and forecasts, it did well. Looks like in terms of the human forecaster here, Dr. Decker, Rutgers, also one of Wisconsin's finest, did really well here at 117. And interesting, some of the persistence forecasts, and their persistence forecasts are what they sound like. They're just, based on what verified over the last X amount of days, 5, 10, 30 days. So if it was, presumably there was some warm periods before this, and that's why the persistence did pretty well here. In terms of some of the forecasts that didn't do as well, I should say most forecasts here did better than the 30-year. This is all benchmarked to the 30-year, so you can see here that the 30-year gets a 0 value. Looks like it was tougher forecasters for some of the forecasters who usually do pretty well here. Professor Roundy, always one of the top forecasters. I guess a little bit too cool on this forecaster, and even some, this is it's a humbling sport, subseasonal forecast, right? So even some of our experts like Dave D'Arcangelo here also struggled a bit in this one, kind of looking at more of a colder forecast. I do want to point out here, Dr. Decker. I was looking at his map earlier because we added relatively recently the forecast maps. So we don't, you're forecasting a number, which is important, but you're also forecasting configuration. And of course, that's helpful because sometimes you're right for the wrong reason and this, that, and the other thing. So here was Dr. Decker's forecast map, definitely very warm. I'm just moving this down a little bit because sometimes the Zoom window gets in the way. I don't know if anyone else has that problem. It's annoying. And then let's look at the verification. I think I pulled it up here. There it is. Yeah. So that's the period. And Dr. Decker really, I don't know if he's online right now, but really nailed this one. Warmth covered, the entire eastern central parts of the country, just a little bit of coolness out west. But this was the case where Dr. Decker not only got the number really right, but also nailed the pattern configuration, which is obviously important, especially, we always talk about industry and stuff. And if you're forecasting for different industries, for example, commodities and stuff like that, a lot of times you're also doing regional. And so, you're looking at Northeast power, Southeast power, things like that. And it's important to get it right. So that was a case where Dr. Decker, again, did really well there. And I just want to look at one other thing. So let's shift and just look at industry here. So this is, let me just pull up, so what do we say here? This is from the 24th. So this is not the right one here. Let me get the right one. So the nice thing here is we can pull up, we don't have all the maps historically, but we can pull up some of the, reports and things from that period, so we can see, hey, what was, what was the world saying? What was the world kind of thinking? So let's do that. And this is, it comes up. This is going to be the Maxar report from that period. There we go. Yep. So this is from November 24th. And you're looking at the Maxar forecast here, pattern configuration. Certainly across the north, it was, I think, pretty good. Obviously, it also verified extremely warm across the south, and that's in part why the HDD forecast came in even warmer than expected. And you can see the models here, the models down below, and it seems like the models didn't handle the warmth in the south. And that warmth was pretty significant, right? I mean, it's easy to underestimate that. Let me show this. With the exception of southern Florida, these kind of anomalies probably correspond to pretty high standard deviations. So, obviously very, very warm also in the south, not just the northern areas there. We can also, let me just X out that because that's confusing. All right, and then we can, let me just look at one other thing here, and then I want to open it up. I just want to look at, I like to look at the hemispheric, right? Because again, that gives us a lot of information about, what the big picture kind of configuration was doing. All right, so there's how things verified, for this period. And now, if we did this right, I don't know if we did, but we can see what the models, we just added this too, we can see what the models were showing. So let me just sort this, make it a little bit easier. So here's CFS. Let's see if this works. Yeah, it's about this period, and let's pull up the EC. All right. So, well, yeah, I mean, you can see certainly why they were kind of cooler in the southeast, right? A little bit of a weakness in the southeast. And then we won't spend too much time on this, but you can see that the ridge definitely drifted a little bit further south than expected. Let me stop there and just open it up here. Anyone on the line have anything they want to share about this forecast? Anything strike them as particularly interesting or important that we should talk about? Everyone can hear me, right?
Hey, Dave, it's Andrea.
Hey,
what do you think? I have a question.
Yeah.
I, did not participate, so I wasn't, preparing a forecast for this period. But I'm wondering, I'm just quickly glancing at some of how people put their forecasts together.
Mm-hmm.
MJO analogs. I saw that Paul Roundy also was thinking MJO also. How did that verify? Did the MJO do what it was forecast to do?
That's a good question. Let's look. So hopefully I've got everything pulled up here. Well, at least we have the EC, so let's just start there. So what, this period we said verified right in the 12th, 13th or so. So it verified in phase 5.
Okay.
I don't have, we made the forecast, what do we say, on the 24th? Is that what I said? I think so, right?
Okay, so late November.
Yeah, so late November. So that would have put it around, I guess it was initialized somewhere in this, it looks like it just got all mumble jumbled, but it was just crossing into phase 4.
Yeah.
So let me just say this, and I think this is, I would love if anyone else has any thoughts on this. So we don't have, or at least I don't have it handy. exactly what it was forecast to do. But in big picture, right? I think we know that um, the the MGO has been like really slow, right? I think a lot of the forecasts have been showing kind of this kind of slow progression through phases 4 and 5, perhaps because of the La Nina Bay state. But I guess my question I have related to that is, does that affect predictability, right? Does that when you have an MJO that's kind of just like very herky jerky like this, for a lack of a bit more scientific, terminology, is that going to impact the longer subseasonal model's ability to make accurate forecasts?
Hey Dave, I just if I could add in a comment, just another. This is Lynn, everyone. So just another person who did not make a forecast. So I'm just adding in a critique here, but not a participant. I think I wanted to reemphasize what Andrea said, because I think that's a incredibly important point, and maybe something to guide us a little bit in putting down our forecast methodologies, in that what did we expect the MJO to do when that forecast was made. I think we're losing a lot of information, by not putting that down. If you're, if analog and MJO was your whole rationale. So I just wanted to emphasize that, because I thought that was a really great point.
We did input that into ours, everyone. I stated in our forecast that the bus potential is trough over the east, coming stronger due to a delayed MJO progression into the circle of death. Also at that time, I don't know if you all remember, the MJO had been stronger than modeled for the past month. It kept on showing that it was going to go into the circle of death, but it was into the RMM space of minus, if you look at the RMM, it was like actually verified at almost -2 in phase 2. So, during middle of November, like I was saying, it was forecasted to be close to the circle of death during that period. And also, Dave, if you go to the CPC website, they do have both dynamic and and statistical MJO verification, but it only goes out to 2 weeks.
Oh, that's right. That's right. Yeah. Let's see if we can get there real quick.
Hey, Dave, this is Greg.
Hey, Greg.
When were these forecasts made again? I came in late. Sorry about that.
Yeah, no. This is November 24th.
11/24.
Yep.
Yeah. So right before Thanksgiving. Yeah. The forecast back at that time, I'm able to pull it up. I'm not going to be able to, obviously show it. Forecasts were showing it coming out of the circle of death and trying to go in a trajectory towards like phase 5. Perhaps some people could have extrapolated to phase 6, but fairly weakly, fairly weak. Excuse me. So that's what the MJ was projected back on the 23rd, 24th time frame.
Okay, you said. Sorry, I was looking. It was projected to be weak.
Yeah, weak, but still outside the COD, going through 4 and 5 in the 1 through 15 day space, and then some people probably would have been extrapolating to maybe a 6.
Right. And I guess a question here too is, how bad? Obviously, Dr. Decker had a very, very good forecast here. Let's look. Get rid of that. So let's just look at what like Paul Roundy was showing in terms of his map. Was it a case of, or maybe even Dave Darkangelo? Let's see if he put it in his map. Okay. That's interesting. I guess Dave. I guess devil's in the details here a little bit. There was actually some cool in the middle, in the interior Rockies, right? Like Dave had. There was definitely a lot of warmth in the south and the east. It's almost like the Midwest, which crucial, right, for heating demand, right? Greg can tell you that. Looks like maybe Dave was thinking a little bit more of a normal kind of pattern for Chicago, and as we saw, those areas actually verified quite a bit warmer, right? With the big ridge right overhead. let's see what Paul was thinking too in terms of his pattern configuration. Oh, okay. Well, yeah. I mean, yeah, Paul had pretty cool in the Midwest, so that that didn't work out. I mean, Greg, do you have anything before we move on in terms of how you think the like more of a global, the hemispheric sense, how the models did versus expectations here? Was it good, bad, or kind of in the middle? How would you grade it?
Let's see. So we're looking at the verification date right here. It looks like it wasn't that far off, so to speak. At least from the modeling, I'm looking at the plot. I was, actually at Thanksgiving at that time, so tryptophan is my excuse. So at that moment, right about that, then there, it looked like at least I'm looking back at some of my progs from back then. Doesn't look like they were too extremely far off. It had some, high level ideas in the same kind of general ballpark. Perhaps once again, was getting too much troughiness into the Alaska vicinity, Northwest Territories. Aleutians was perhaps a little too much there, and that kind of caused people to have that bit of an issue.
Yeah. Yeah, it's interesting though. And I pulled up the EC here on the left, and I guess what I mean, right? What stands out, at least to me anyway. I mean, I don't know. Oh God, you can spend hours on these things, right? But I mean, clearly, it doesn't look horrible in some areas, but it looks pretty bad where it counts, like the Midwest and Southeast, right? Like, I mean, this is a big error from Chicago to Atlanta, right? Chicago to Atlanta, there's a pretty big ridge that verified. For Chicago to Atlanta in the EC forecast for that period, you're thinking kind of, you know, you're thinking not that, right? At the very least. I mean, it's kind of, it really, and there's even a little bit of a weakness that verified out west. The more I look at this, and maybe I'm playing Monday morning quarterback too much, but when I look at it across the United States, oh boy, yeah, I can understand why there were forecasts out there that were a lot cooler than what verified, right? I mean, across the United States, continental United States, it wasn't great. When you look elsewhere, it's not like across the North Pacific, there was a lot of blue. There was some blue that verified. It wasn't a horrible, forecast across North Pacific, but it was definitely more progressive. So I don't know. Maybe we don't have any answers. But before we completely switch gears, does anyone want to add anything else here in terms of maybe a lesson learned that we can apply to the next forecast? Okay.
Dave, I just want to point out with these two map projections that you have up right now, there's a huge difference between the two in terms of when you look at the blue over, there's really just a displacement in location, say over the Northern Pacific. But in terms of the size, it looks much larger on the map projection on the left than it actually is on the one on the right. When you look at the landmass size.
Oh yeah, this one is bigger. Yeah, I didn't.
Just pointing that out. I don't know if that'll be helpful going forward or not, but in analyzing these two, there's some differences there.
Yep. Okay. Well, subseasonal forecasting is humbling, but this is what makes Greg's job so hard, I guess, right? Trying to pick out those details. All right. Let's switch gears. Let's talk about the forecast. And I think, Andrea, this is a great time, if you don't mind. Maybe if you can give folks a little information on your background and your research and things like that.
Sure. Yeah, so as Dave said at the beginning, I'm a faculty member at the University at Albany, where we're still digging out from snow. But yeah, so my research area, I started really interested in synoptic meteorology. And as I've continued, I've gotten more interested in sort of the medium range than the extended range into subseasonal timescales. And I'm really interested in the dynamics of weather systems as they form at the tropopause, which then led me into thinking about how the stratosphere is involved. So I would say my background is a little bit unique in terms of people who think about the stratosphere, because I'm coming at it from the weather side and not the climate dynamics, fluid dynamics side of things. I mean, that's definitely a big part of it, but I'm really interested in, okay, but what does this mean for weather? So in terms of where some of the things that I'm doing right now, I was a co-lead of NOAA's S2S prediction task force. And so that just wrapped up, and we put together a special collection of research papers in the AGU journals on topics of S2S predictability. And so I think there's something like 100 research papers in that special collection. And you've probably seen this before, but let's see, can I share my screen?
Yeah, of course. Let me stop
Okay.
sharing my screen. Okay.
Let's see this one. Okay. So this is from the introduction to this special collection, and we put together this figure. So really, I'm sure all of you know how complicated making forecasts is at this time range, but really there are people working on every single aspect of thinking about subseasonal prediction, but all of these things are connected, and really trying to untangle it either after the fact or especially during real time is extremely complicated. So everybody who makes forecasts and does this for a living, I'm extremely in awe of. But yeah, so this is one of the figures we put together, and really making forecasts at this time range isn't just about thinking about the physical processes that go into making forecasts. How is this ridge going to impact the temperatures 5 days later downstream, over Scandinavia? It's really also about thinking about things like, okay, well, why do I trust this model? Tell me something about how it generates its ensemble members that makes it more skillful in predicting things that are going to happen at weeks 3, 4, and 5 compared to this other model. And then we also have to think about the systematic biases in the model. Radiation schemes become important. Does this model do a good job resolving teleconnections starting in this location versus this other model? So there's a lot of things that go into this that go beyond just the physical mechanisms that lead to one pattern versus another, but also about the mechanics of actually modeling these things. And so I'm definitely on the physical processes side, but I've really come to appreciate all the things that go into making the forecasts. So with that being said, let me pull up. So one of the things I am part of this group that is an international group that is really trying to collaborate to put out information about the real state of our ability to make forecasts about what's going on in the stratosphere, because the stratosphere, when it's in an extreme state, can have impacts on the subseasonal timescale, especially during the Northern Hemisphere cool season. And so last year, I think this paper came out. It was probably a little bit before then. But we went through all the models that contribute to the subseasonal to seasonal prediction project, and we identified, extreme stratospheric events that we put into categories of early season weak vortex events. So these are the kind of things like that we saw happen at the beginning of last 2019's winter season, where the vortex started to weaken. It never really became a sudden stratospheric warming, but it still had some impacts on the forecasts and implications for what people were preparing for the rest of the winter to look like. We looked at strong vortex events, sudden stratospheric warming events, negative heat flux events, which I'll get into in a second, and also final warming events. And basically, from subseasonal prediction perspective, we binned all the forecasts into lead times of 5-day bins. And the takeaway is we really only have skill in forecasting these extreme stratospheric events before they happen at timescales of 6 to 10 days. So even though they have huge implications on the subseasonal timescale, our ability to resolve them before they happen is not great. So that's kind of unfortunate. So then the question is, okay, well, once we resolve them, how can we use them to say something about what's going to happen, 3, 4, 5 weeks from now? And that's the question that we're starting to really get into is, when does a sudden stratospheric warming have a temperature impact on North America versus Europe versus somewhere else? And how can we be able to resolve or detect the outcome as the event is happening, as opposed to, in the middle of the event or when it's too late? So right now, the research is still sort of hot off the presses, and there's still a lot of questions and debate in it, but that's some of the things. That's my background. That's what I'm doing. I'm definitely on the how does this happen, and do the precursor conditions in the troposphere have implications for the outcomes side of the research. But that's a little bit about my background. So I can stop there, and then I can transition if there aren't any questions. Maybe, no questions?
I have a question, Dr. Lang.
Sure.
So I was looking, so we have a forecast period. When I was looking at it, there is anomalous highs almost directly over the pole.
Yeah.
Is that indicative? Because there's also a slightly negative AO and a positive PNA. Is this like an indication of a sudden stratospheric warming event?
So that's a good question. The way that sudden stratospheric warming events are defined is based on the zonal mean wind at 60 degrees north at 10 hectopascals. So if those winds transition from a westerly direction to an easterly direction, that's when your sudden stratospheric warming event happens. And so if you think about that, it's pretty, I'm trying to think of a good way to put this, but I mean, sometimes just because the wind's reversed doesn't really have an implication for the large scale pattern. It just means that you have a ridge over the polar regions in the stratosphere when normally you would have a trough, the vortex. So where that vortex goes isn't in that description of a sudden stratospheric warming event. It could be pushed off the pole towards Europe, or it could be completely split into lots of little pieces and be completely gone. So yeah, I mean, it's hard to say. It definitely means that the planetary scale pattern is amplified. But in terms of what the outcome is on the stratosphere, it isn't obvious just based on having a ridge over the polar regions most of the time.
Okay.
Yeah, I appreciate that input because a lot of people in the weather world, what they'll do is they'll just show the 10 millibar temperature maps.
Yeah.
And they'll be like, it's a sudden stratospheric warming based on a bunch of red on the anomaly. And you're like, it's a little deeper than that. But, and like you said, it's a matter of the winds also. And a lot of things that I've seen people do is they'll show like, it's on the CPC website also. And off the top of my head, I can't remember where it is. But it's basically, it focuses on obviously the Northern Hemisphere, but it does a lot for like Asia and the North Pacific. And if you see like a ridge that all of a sudden pumps up into the Bering Sea region, that's indicative of perpetrating the, whether it be moving the vortex over into the North American region, because that's another thing that, as you bring up, a lot of people that talk about sudden SSWs they automatically assume that it's going to benefit the United States, of course, because of their bias. And, if they came up with a cold forecast during a certain period, it doesn't necessarily dictate that it will benefit North America. As you said, it could go to Europe for all we know, could go into Russia, into Siberia. We just don't know. And a lot of people that complain about like the NWP at the 500 or at the surface, like days 15 or anything 11 through 15, they'll be complaining about it, but yet they'll turn around and actually show the 10 millibar picture for the same period. And you're like, wait a second, wait, didn't you just say that you can't trust the models? And now you're showing a day 15, 10 millibar, saying that.
Yeah, you can bring up this figure that shows how poorly they're able to resolve variability in the stratosphere at day 15.
It just cracks me up, Doctor, seeing that all the time. It's like,
yeah. I mean, it's a definitely that happens this time of year. But yeah, I mean, it's really interesting because yes, you can look at the winds and they're going to decelerate. In fact, my former grad student, let's see, I'll look at this one. She put together this website that's still active where she looks at the forecast of the zonal mean winds at 10 hectopascals. Here it's 65 north. But generally you get the idea that, okay, well, we have westerly winds in the stratosphere, sort of mid to high latitudes. They're westerly at 30 meters per second. And in the forecast, they're going to intensify and then maybe weaken. And some of the ensemble members out, around the new year, weaken the vortex pretty substantially while others keep it about the same. And there's already discussions about, what does this mean? Is it, is there going to be an SSW? And it's too, the GFS is too far out to actually resolve an SSW reliably. But what I do, and let's see if I have this open, hopefully I do. Okay, so this is also a GFS forecast. And this is a map I have on my university webpage. But what you're looking at here, there's a lot going on, so I'll walk you through it, this is the 45 to 75 north departures from zonal mean geopotential height. So basically it's the wave structure in the mid to high latitudes. So everywhere you see red, at that latitude is going to be ridgy. Everywhere you see blue at that latitude is going to be trophy. But it goes from 1,000 hectopascals all the way to 1 hectopascal. So you see both the wave structure in the mid latitudes in the troposphere, but also the stratosphere. And I like to look at this because, I added on this side, and I don't know if you can see my cursor or not, but all these line plots are vertical profiles of variables that are important for thinking about troposphere stratosphere coupling. And so the first one is the zonal mean wind going from 1,000 hectopascals to 1 hectopascal at 60 north. So this is the one that we use to define a sudden stratospheric warming event, but it is only at 10 hectopascals. So it's only at one point on this line that we use to actually in the literature define a sudden stratospheric warming. But you can see that just looking at this forecast, there's a lot of variability of the zonal mean wind in the stratosphere. And in fact, towards the end of the forecast period, you actually see the wind at 1 hectopascal reversing, which means the upper stratosphere is experiencing the wind reversal while the mid stratosphere is not. And this can have implications on the evolution of the stratosphere. If you think about going back to your wave dynamics and everything, as soon as you have easterly winds, it means Rossby waves can't propagate through that region. So all of a sudden, this is creating a situation where if you have Rossby waves there, they're going to have to start breaking or something is going to happen. And anytime you get wave breaking events, it means, it's a mess. Forecasts are really bad at identifying wave breaking and then being skillful after that.
I was going to say your verification drops significantly.
Oh yeah, absolutely. So in the stratosphere, when we're thinking about wave breaking, we're talking about a hemispheric event. So yeah, waves in the stratosphere are like, you have a trough over Europe and then you have a ridge over Alaska and that's your wave. So it's huge. But the interesting thing is that as this happens, the wave structure, we have the westerly tilt of the wave with height. So if something happens at the top, it kind of trickles downward. And you can kind of see this, but of course, this is a forecast. Who knows if it will verify, especially at these long lead times. But the dynamics are still consistent with the physics and everything. So this is one possible outcome. And so by looking at this is how we try to learn about what is actually going on. And what I find really interesting is that once we have this deceleration of the winds in the upper stratosphere, if you start looking at the amplitude of the other planetary waves, so the red line on the far right is wave 1, the orange line is wave 2, and then I used a different panel because the amplitudes are a little bit less. The blue line is wave 3, and then the purple line is the synoptic scale waves. And so what's interesting is you can see how each one of the waves kind of change their contribution. And so as this process is going on, we can see that the synoptic scale waves on the tropopause amplify. And I think that is going to be the part that's especially meaningful for us, living in the troposphere, is that already I've seen people talking about this potential storm at Christmas time for the East Coast. And you can kind of see that it's trapped underneath this huge planetary scale wave structure. So depending on how this ridge sort of in this, North Atlantic region phases with the ridge in the stratosphere, I think we might see there's going to be a lot of variability in the forecasts out at that time range.
By the way, this website is awesome.
Yeah.
I'm loving it.
Oh, yeah.
The wave 1, wave 2, wave 3. And then, of course, like you were saying, the purples 4 through 7. Oh, I love it.
Yeah, and really that to me is just like, once you get past day, 10, it's sort of like, high amplitude synoptic waves. Who knows what's gonna happen? The phasing is what becomes important.
I'll add to that. I think this is pretty amazing. I love this view of things, and especially watching the soundings move along in time. That's definitely pretty cool.
Now, also real quick, Doc, is this only for the 18 Zulu, or do you do this every 6 hours?
So I only run this for the 0Z GFS. So it's once a day.
Oh yeah, I'm sorry. I saw the 18. Sorry.
Oh yeah.
I automatically thought 18 Zulu. Sorry.
And for what it's worth, I have one for the Southern Hemisphere, but the Southern Hemisphere is pretty boring right now. They're in, stratosphere summer is kind of boring.
That's
But
great.
yeah.
Andrea, was there, I'm sure, I know I have some questions, but before going to that, was there anything else in particular you wanted to share?
Not really. I was going to sort of go with the discussion after this.
Okay. I guess one of the things I'm curious about, and feel free, I know your day job isn't to make a 20-day forecast and that kind of thing. But is there anything that you're seeing that you think is of interest for the upcoming winter, one way or the other, in terms of stable, unstable, predictability, cold, warm, anything strike you?
That's a good question. The big question for stratosphere people is, will this winter have a sudden stratospheric warming? And every year for the past, I don't know, maybe 5 years, Daniela Domayasin, who's at ETH in Zurich, has a contest. And basically, is there going to be one, and what will the date be? And you have to submit your information, before December 1st or something. And the number of people who work on the stratosphere that are just completely off their rockers with their forecasts is pretty high. So, I mean, I would say that even though I stare at this type of stuff all the time, it confuses me every time I look at it. But with that being said, the fact that it's a La Nina year and we already have this phasing of the planetary scale waves in the stratosphere that appear to be receptive to a forcing from the troposphere. And by that, I mean that you can start to see the westerly tilt with height in the forecast. I think that if the MJO moves from phase 5 into phase 6, and it's still active in phase 6, then we're going to see an active stratosphere in the S2S timescale. I think that right now the forecast shows some variability in the stratosphere, but I think that's really going to be amplified if we have the MJO in phase 6. And I say that because if you look at the phasing of the stratospheric waves, and then you think about where you normally have ridges and troughs during periods of phase 6 of the MJO, it perfectly aligns with where you need them to be to match what's going on in the stratosphere. And I say perfectly, really by that I just mean pretty good. And for that, I think if that happens, then we'll see the potential for extreme conditions in the stratosphere, which may mean something like an SSW. So
Cool.
yeah, that wasn't really a forecast. It was more of a, oh, maybe there might be something happening if all these other things fall in line.
Okay, and that would be something, if that all comes together in that extreme way, in terms of impacts in the mid latitudes, is that like a month out? Is that, like, is there a time frame where we would see the impacts?
That's a good question. So typically, it's in the week or so after the MJO is active in phases, I think it's 6 and 7, is when you see the impact on the stratosphere. And then after that impact, it could be anywhere from a pretty quick response in the troposphere to out to a month or so impact on the troposphere. So if you were making a S2S forecast now, I think now is the time to think about, okay, well, what is the MJO doing? Does it look like it's going to be active? Because we might see some cold conditions in late January if the MJO does move into late phase 6, but before the end of the year.
Okay, thank you. Anyone else have any questions about the stratospheric research here that Andrea is doing, or how it's related to medium range or this winter? I had while folks are thinking, I just had maybe you touched on you touched on something about the Christmas time period. You said volatility or predictability, or I think you said volatility, but excuse me. Is there? I mean, have you? We always get into predictability. I mean, is there? I mean, does the what's the question I'm trying to ask? I mean, do you feel like, based on what you've seen, that there are regimes of the stratosphere that have significant impacts on numerical model predictability out, 10 to 20 days? Like if you see a certain stratospheric regime, you can say, hey, maybe even generically, like just, hey, this is a lower confidence type of regime versus high confidence. Have you seen it that it can have that much impact on predictability, or do you have thoughts on that?
Yeah, actually, there's papers that have looked at this and basically looked at the initial conditions in the stratosphere and used that to assess subseasonal forecast skill using something like the 500 hectopascal geopotential heights as the skill metric. And they've shown that if you initialize a model when the stratosphere is in an extreme state, and basically that's the zonal mean winds are, in the top or bottom 20% of the climatology, then you have increased forecast skill for like the entire, and actually I'm working on my AMS presentation and have that slide here. Let me, hold on, stop sharing and then reshare that slide. So you can see this bottom panel right here is when we have forecasts at S2S models initialized during weak or strong vortex conditions. What are the anomaly scale correlations for the NAM? And this is the 1,000 hectopascal NAM. So essentially the AO at week 2, week 3, and week 4. And all of the forecasts initialized in weak or strong vortex conditions at those time scales have higher ACC values. And it was statistically significant in this paper from Tripathi et al. In 2015. So in terms of regional skill, I don't think anybody has done that analysis.
Okay. Thank you.
Yeah.
So I think that's a good research question that kind of leads into my question, which would be a little bit more general, but for some of the students that are online today or that will listen to this going forward in the future that are sort of searching for a niche in the S2S world, what do you think are right now are some of the most important research questions that we have to answer just in general for S2S predictability?
Yeah, in general, I mean, I think there's so many questions. And one of them is, I think the biggest one right now is, okay, great. I know that there's more skill if I, for example, initialize my forecast during a weak vortex event. But what do I do with that information? It doesn't mean it's perfect skill. It just means there's slightly more skill. So how do I use that information to do something actionable? And I think it's that sort of transition between, great, look at this research result, and what do I do with this, is really the place where work needs to be done. It's sort of, okay, there's a lot of people working on the research side, but how do we apply this? And how do we do that in a way that's actionable and meaningful is a good area of research. Or if you're interested in sort of the physics and the dynamics and the process side of things, motivating those questions with that, okay, how is my result going to be used by other people?
Mhm.
Yeah.
Great, thank you.
Yeah, no, that's a good question.
Right. Any other questions for Andrea here? I guess we have a few more minutes. Let's see if any of our student members here, maybe Michael or Sean, want to take a couple minutes and just share their forecast process for this week. We can talk about that a little bit. And Andrea, you can grade them.
I've had enough grading for the semester, thanks.
Who wants to go? Michael, would you like to give it a shot?
Yeah, sure. Let me just.
If you want, you could share your screen.
I don't think I need to.
Okay.
Just.
I'll share my screen then, just so everyone can see.
See what I wrote. This is this week's forecast, right? You said.
Yeah. So why don't you and this will be helpful for Andrea, just kind of walk through your forecast methodology and process a little bit, and then folks can ask Michael questions about his forecast.
Okay. So my forecast was 136.9 HDDs with what I guess is an average spread. There was no, I didn't see the spread on the website this week. Some kind of glitch. So I just went with 25. Assume that would be near average. Started off as I usually do with a blend of the 10-year average and the euro. Had some success with that in the past. So I started off, got a base value of 100 and, oh, wait, did I put in the wrong number? Hold on a second. Because my numbers are not matching up with what I wrote and what I have in the, I think I put in the wrong number on the forecast page. My actual number is 144.5. So sorry about that.
No problem.
So I took a look at the CPC, showed a lot of warmth, pretty much across the board. Whole country has at least a 60% chance of it being above average, I believe, if I remember it correctly. And then I took a look at the teleconnections, which is the other half of my forecast, and found that most of them were kind of at odds with what the CPC was showing. And basically, as I said, they're canceled each other out. So essentially, I'm just running with an average of the euro and the 10-year. Since there was no clear signal other than in the AO, which by itself I didn't think warranted a very large change in what I was thinking. So I just stuck with near average conditions. Any questions, complaints, comments, concerns?
No, sounds like sounds like you've got the perfect forecast then. No criticism, no comments.
I can only hope.
All right. I'm thinking, why don't we, Andrea mentioned that, you might need to leave a couple minutes early. So why don't we just leave it there? Give folks maybe one last chance, see if there's any questions for Andrea. But I think it was great having you here. It was great focusing. We talk a lot about MGO and stuff, it seems like, in our weekly discussions, but not too often do we get a chance to have an expert who can tell us a little bit more about the stratosphere, and especially this time of year. I think it's going to be really helpful. I think it was really helpful to hear all the interesting research topics that are going on right now. So thank you so much.
Oh, no problem. It's always exciting.
Yeah, and hopefully we can have you back again, at some point in the not too distant future. And we'll definitely look for, I think, to see what happens here over the next couple months, and see if we do get some more extreme weather. It seems like we're off to a good start anyway across the eastern parts of the country.
Yeah.
And if that, I mean, you talked about the Christmas storm and that cold front in general, and that air mass. If some of the models are right, it could be an interesting Christmas weekend there for some of us here in the Northeast and East Coast in general. So in Midwest too, for that matter. So,
Yeah, the Midwest.
yeah. Okay. Well, yeah, thank you, Andrea, and thanks for everyone for participating. I think it was a great discussion. And I should mention, Zach's going to send out an email in a couple days, but we're going to take a couple of weeks hiatus here we normally do this around Christmas and New Year's, just give folks a couple of weeks to, so they don't have to do the forecast and can focus on other things like family and friends. So we'll send out an email, just remind everyone, but we're going to take 2 weeks off from the forecast contest and resume again after the new year. So thanks everyone, and have a good happy new year and holidays and everything.
Thanks again, Dr. Lang. Awesome presentation.
Oh, thanks. And thanks for coming. Have a good weekend.
You too.
Thank you.
Bye, guys.
Dr. Lang.